During the course of this presentation, we'll cover periodic engine and chassis maintenance, engine removal, engine overhaul and component reconditioning, and engine assembly. We'll also cover carburetor service, electrical systems operation and troubleshooting, and we'll finish up with fork rebuilding. Because motorcycle chassis components have become far more sophisticated during the past several years, chassis maintenance is no longer something to be regarded as unimportant. In order to maintain handling, braking, and ride qualities, it's very important that the chassis components receive the same attention given the engine. During this portion of our program, we'll look at brake system maintenance, steering and suspension maintenance, and in general, cover all the chassis-related items that will, from time to time, require attention. The Venture Series unified brake system is similar in operation to the type used on the earlier 1100 models. The left front brake and the rear brake are actuated by the rear brake pedal. As with the 1100 unified system, a proportioning valve is used to control the amount of brake fluid pressure being fed to each caliper. But on this system, an additional metering valve also aids in controlling front brake pressure under certain conditions. In effect, the addition of this valve ensures that the rear brake always begins to work slightly before the front. Neither the proportioning valve or the metering valve should ever be disassembled. Now, bleeding air from this system requires a little more care and patience than most normal hydraulic systems. There are a number of high spots in the system where air can be trapped, and you may find it necessary to bleed some of the fittings in addition to the normal caliper and anti-dive bleed locations. Recommended brake fluid is DOT3, not DOT5, and exercise care, especially when working around any plastic fairing pieces. Brake fluid will very quickly destroy painted or plastic surfaces. The overall weight of this unit places a good deal of load on the brake pads. Wear will vary according to the type of use this machine sees, and brake pad inspection should be considered part of any routine maintenance service. A visual inspection of the pads is possible without removing them from the calipers, but removal is so simple that we suggest you take the time to do the job properly. After removal of the inspection cover, the pin clips and pins, the pads can be lifted clear of the caliper. These pads have been designed to tolerate wear down to a friction material thickness of 0.5 millimeters. In other words, even when worn close to the limit, brake effectiveness will remain constant. The area of concern here is that local regulations pertaining to brake wear limits must take precedence over any factory specification. Now, these pads are of the metallic variety, and we've had a few mechanics voice concern that the disc rotors on a few Ventures appear to be grooving badly. The specified rotor thickness is 8.5 millimeters, and if you were to actually measure one of these supposedly worn discs, you'd likely find that very little, if any, wear has occurred. Metallic linings such as these will often etch the rotor and cause slight grooving. This is considered normal and does not affect brake performance. Precise handling doesn't just happen. It's the result of proper design geometry and suspension characteristics suited to the size and weight of the machine. Misadjustment of either suspension or steering components can lead to less than optimum handling, and it's up to you during routine maintenance service to ensure that these adjustments are correct. Fork oil changes are recommended every 24,000 kilometers or 16,000 miles. Before starting the job, bleed as much air as possible from the front suspension. With the full weight of the machine on its wheels, you should be able to reduce pressure to 0 on the standard model and low enough on the Royale that it won't cause problems when the oil bleed screws are removed.
In order to gain access to the fork caps, it's necessary to remove the upper face panels of the fairing. On the Royale, remember you've got speaker wires to disconnect. There's nothing complicated about draining the fork oil, unless, of course, you've forgotten to drop the air pressure first. Since these forks do hold a substantial amount of oil, it's a good idea to let them drain for several minutes before reinstalling the plugs. Removal of the fork caps is next to impossible if you don't first loosen these pinch bolts. You'll need a 17mm Allen drive to remove the caps. Refill each tube with 400 cc's of high-quality 10-weight fork oil.
Now, removal of the upper fairing pieces is not necessary to perform steering head bearing adjustment. But since this adjustment should be performed as part of any suspension service, we'll cover it now. Both the Venture and the Venture Royale models are equipped with tapered roller bearings. Because their load-bearing area is far greater than that of a ball-type bearing, they can very easily be over-tightened. If they're adjusted too loose, they'll produce a clunking noise. If they're too tight, handling will suffer.
Start by elevating the front end using an appropriate stand. Rock the fork tubes back and forth and determine if there is any play in the bearings. If there isn't, we know they're not too loose. But what about too tight? If any resistance to movement is felt as the bars are turned, they likely are too tight. Correctly adjusted, the bearings will exhibit no free play. But when the bars are given a gentle push, the fork should hit the limit stop and return to approximate center. If adjustment is required, loosen the upper fork tube pinch bolts and the crown nut and remove the battery. Adjustment is then performed in the usual manner. As you turn the adjuster nut, check the movement of the bars. When they respond properly to a push, lock the adjusters in place. Torque the crown nut to spec, 11 meter-kilograms or 80 foot-pounds, and recheck your adjustment. You'll find that even if your adjustment was only slightly on the tight side, the force applied by torquing the crown nut will cause the bearings to tighten up.
Steering head bearing adjustment on this model takes some getting used to, but once you've done it a few times, you'll have a good idea as to how the adjustment should feel prior to applying the specified the crown nut. You'll learn that you have to compensate to some degree during bearing adjustment for this torque load.
Two other items related to front-end maintenance that should be inspected. The front fork brace, in order to do its job, must be torqued to 2 meter-kilograms or 14 foot-pounds.
To aid in isolating the rider's hands from vibration and to enhance steering stability, the handlebars on both Venture models are weighted. The rubber caps at each end and these two O-rings should provide proper fit to the bar. But if these weights do come loose, they can cause an annoying rattle. The use of O-rings of a slightly larger diameter or simply taping the weights will cure the problem. Now, while we're on the subject of front ends, we should look at the anti-dive valves used on this model. There seems to have been some confusion as to the proper adjustment procedure required for these units. They are different internally from those previously used, and perhaps the best way to explain adjustment would be to first show you how this system works. Let's have a look.
As with the original Yamaha anti-dive system, suspension dampening is controlled inside the anti-dive unit rather than inside the fork assembly. On compression and rebound, oil is forced through and controlled by the gap between the anti-dive plunger and seat. When the brakes are applied, brake fluid forces the plunger down towards the seat, restricting the flow of oil and limiting fork compression. During braking, if a bump is encountered, fork oil pressure will rise behind the valve. Once this pressure is sufficient to overcome the pressure applied to the bottom of the seat by the valve seat spring, the seat will move away from the valve and fork oil will momentarily flow past. This momentarily overrides the anti-dive effect, and allows the suspension to absorb road surface irregularities. As this fork oil pressure decreases, the seat will return to its closed position and the anti-dive effect resumes.
Now, to increase the anti-dive effect, this adjuster must be turned counterclockwise. To reduce the effect, you turn the adjuster in or clockwise. This is the reverse of our previously used anti-dive valves. Let's see why.
Working against the brake pressure that's trying to close this valve is the pressure applied by the spring. Turning the adjuster clockwise applies more spring pressure to the valve. That, in turn, requires more brake pressure to overcome. Backing the adjuster out decreases spring preload and allows the anti-dive effect to occur sooner and with less brake pressure.
One last point about this system. Because the anti-dive valves are actuated by brake pressure, and the left and right units act independently of one another due to the unified brake system, full anti-dive effect will not be achieved unless both brakes are applied. If a customer voices this concern, make sure that he's been using the brake system properly before you do any troubleshooting. The next item on our maintenance list is chassis lubrication.
80 or 90 weight gear oil, preferably with an EP factor, is recommended for the final drive unit. Fluid level is measured using the gauge supplied in the toolkit. Lubrication of the rear suspension linkage should be performed at each service interval. A dry moly spray works well for this application. It's also an excellent lubricant for brake and shift linkages. No maintenance service is complete until you've covered the entire unit from front to back. Each interlock component, such as the side stand switch, clutch switch, and engine kill switch, should be checked for proper operation. Wheel bearings and tires should be inspected and tire pressure verified. Make sure everything is secure. Wipe off any oil or handprints, and finally, do your road test.
Now, you've covered every item listed on the maintenance schedule. You've inspected the machine thoroughly, and you've spent a good deal of time doing it. That must be it, right? Wrong. Your customer deserves to know what he's spending his money on. A work order that simply states 6-kilometer service doesn't tell him much, so take the time to list the work you've done and any items you feel may need further attention. Show your customer you're really concerned about his being satisfied with both his machine and your work, and chances are he'll return to your dealership.